Okay, I wanted to ask my TA to show you how to use this one, but it turns out he's very busy now. So I decided to do it myself. So let's look at this one. We have number 4 of chapter 8, right? So the question is about a manufacturing company's quality control personnel have recorded the proportion of defective items for each of 500 monthly shipments of one of the computer components. And the data are in the file here. You look at this Excel file, that's the data, right? So you have a shipment here, and then let's say we have the total population is 500. So it's not that big, right? It's not that big. So somehow we can use the whole population to make any inference, but because we are learning how to use the sampling to make that estimation, why don't we follow this confidence interval estimation using sample? So the first part A, is use start tools to generate a simple random sample of size 25. It should be easy, right? The first thing is we need to define data set, and let's go to here, and then we define the data set here. So the data set number 1 is A1 to B501. That's exactly what we want. So now we have the data. And then the part A asks about to generate a simple random sample, right? So why don't I go to this data utility, and then there is a random sample, right? So I selected this one. And then what I want to have is this, okay, let's say shipment proportion. It should be okay. Number of sample, meaning that how many different samples do I want to have, right? But now I don't need to have many different samples. So let's say just we need one sample. And then the sample size, meaning that this is n actually, right? So how many elements from population we want to include in our sample? Exactly 25, because we are working with the sample size 25, okay? And I already mentioned this one, a sample with the replacement to a sample multiple variables, includes blanks in samples. Sometimes you need to pay attention to these technical, differences or technicalities. But for the time being, let's forget about these things. We want to have very simple, very straightforward discussion. Okay, you click it, and then that's the outcomes. In other words, the start tools helps us to select 25 elements from the population, which contain 500 different data points. So it turns out that Excel chose 84, 34, 54, 5, all the way up to 284, and then we have proportions. What we need to know, what we want to do is to make confidence interval for the proportion, right? Okay, let's go to part B. Using the sample generated in part A, construct a 95% confidence interval for the mean proportion of defective items over all monthly shipments. And there is some conditions. Assume that the population consists of the proportion of defective items for each of the given 500 monthly shipments. That's just some technicality. So why don't you just go directly to how to use start tools to calculate confidence interval. We go to, let's say, statistical inference, right? Statistical inference, and then it has confidence interval. And then it asks about mean and standard deviation of proportion. And in this case, we are interested in the mean value, mean of this proportion, right? So it's kind of a little bit confusing because already the data says that it's a proportion, but when it comes to make a difference between mean and standard deviation and proportion, we are interested in mean values, average defective proportions, right? So we click this, and then it asks us about this data. Okay, what I want to do is I want to use this random sample. I want to use this random sample when I, estimate this confidence interval. But in order to do that, I have to define this. Random sample as my data set, right? Because when I just click this confidence interval estimate, it asks me about data set number 1. Data set number 1 contains all these 500 data points. So this is not what I want. So I needed to define this data set again. Now I have data set number 2 from A1 to B26. That's exactly the random sample. Very good. And then I go to, again, this statistical inference, and then confidence interval, and mean and standard deviation. Especially, forget about the standard deviation. We are interested in this mean, average value. We want to estimate the confidence interval for the mean, average of the population. So now we have data set number 2. Okay, it asks me about the right question. Okay, so we want to work with data set number 2, and then especially we are interested in this proportion. And we wanna make a confidence interval. We want to make a confidence interval for the mean value. You see there is an interesting box, which is known population standard deviation. If this is known, you needed to check this box. But then what do you think it would happen? If you check this box, probably they will use G values, not T multiples, right? Because if we already know the population standard deviation, then it's very simple. We can use normal distribution and G multiples. But we do not know, and therefore I don't want to check this box. Then therefore stators will use a T distribution. So for the mean value, I want to calculate the confidence interval and confidence level 95%. Okay, that's the problem asks us to do. Okay, let's do it. Okay, so that's the outcome. It's easy, right? Quick and easy. So now you can see that sample size 25, sample mean 0.4396, and sample standard deviation 0.2818. And we have a confidence interval, confidence level 95%, and degree of freedom 24. Why? Because it's n minus 1. And then the lower limit and upper limit. What this means is that what is the probability that, let's say, 0.3233 and the true defective rate is, that's what it says. That's what it says. Okay? True defective rate. Okay? True defective rate. Let's say proportion of defective. Okay. So true defective rate is between 0.3233 and 0.5559. I would say that. And when I say that, how much confident am I? I'm confident as much as 95%. In other words, I'm pretty much sure the true defective rate will be between these two values. Okay, that just I did just part C. What is the interpretation? What is the meaning? What is the meaning? And this is going to be an interesting question. Does the 95% confidence interval contain the actual population mean in this case? Okay. How can we check? Usually we cannot check in reality, right? Because we do not know the true value of population in most cases. But again, this is an example, and we actually have all this population, and it happens to be that the population has only 500 data points. So this is a unusual case, but still it will be an interesting one. Okay, so why don't I take the population mean, where this is a summary statistics, one variable summary statistics, data set number 1 and proportion. Okay, let's see. All right, let's say mean value is this 0.5025. That's population. That's population mean. And the question is that whether this value is within this range or not. Okay, it turns out it is. Okay, let's say the mean value, population mean is this one, and then let's say okay, so that's actual population mean, and as you can see, it's very clear that this value is within this range, and I hope that it is very straightforward. Otherwise the estimation itself does not have any meaning. Okay, so this is very nice example, and you can see that you can use stat tools to estimate the confidence interval for a certain variable you are interested in, and I think that this helps us a lot, and especially if you feel that it's not easy to estimate the t-multiple yourself, then this is a nice way to get this confidence interval. But I want to emphasize this. Although you can use stat tools to get confidence interval, if you truly understand this fundamental logic or principles of about how to calculate confidence interval, you should be able to estimate this t-multiple yourself. Okay, and therefore I strongly recommend that in addition to using stat tools, you should make sure you can calculate confidence interval by calculating the t-multiples by yourself. Okay, all right, very good. All right, did you enjoy the lecture? This is a very innovative way to deliver my lecture to you. And although I'm not here physically, you remember that I'm looking at you, right? So I'm right now looking at one of you, so I hope that you paid your attention to this lecture. Why don't I close this lecture by looking at this lecture note. You already got this lecture note, confidence interval estimation. And these are all we already talked about. Statistical inference, especially why it's important to estimate this confidence interval. And obviously, if you understand confidence interval very clearly, then you will find that it's very easy to understand hypothesis testing, which is our next topic. And the g-value here, as you can see, this is the g-value, right? This is the g-value, and the g-value is assumed that if we already know the true population standard deviation, right? But because we do not know sigma, which is unknown, we use S. And if we use S, then we gotta use T distribution. That's what I already told you, right? That's called the T multiple or T value here. And the degree of freedom, n-1. So T distribution looks very much like a standard normal distribution. That's I already talked about, right? And the only difference is the T distribution has a heavier tail, a thicker tail. But as n, the sample size increases, the T distribution very rapidly, follows normal distribution. It becomes closer and closer to normal distribution. And, in your lecture note, there is a chi-square and F distribution. Forget about this. Forget about this for now. I'm not talking about this. Probably F distribution will return to this concept when we talk about regression analysis. But for now, for the time being, forget about this chi-square and F distributions. This is not what I want to talk with you. So confidence interval, confidence level, 90%, 95%, 99% usually. And here, X bar plus minus T multiple times standard error, okay? SE is standard error, which is here, S over root n. And all the others, I already mentioned. The reason I go over this lecture note is that the lecture note contains more than what I taught you. So I just want to make sure that you don't have to pay attention to the subject, to the topics I do not teach you in the class. So what we are interested in is this, confidence interval for the mean. So that is an example. So I want you to go over this example yourself. And confidence interval for total and confidence interval for, let's say, proportion. What I want to say is that you may forget about these things, okay? So if we look at this lecture note, what is relevant is up to this point, okay? So what we have done is our confidence interval for the mean values, and that's the only thing I want you to understand. The topics following this, the topics after this slide, you don't have to worry about. You don't have to be concerned with, okay? All right, really nice, really nice. I'm very happy to test this new way of delivering my lecture to you, because this is the best choice I can think about. I can think of, considering all these complex situations. Okay, so I'm recording this lecture in KAIST main campus in Daejeon. So I will return to my classroom physically very soon, but probably we will have several more of this kind of lectures. And I hope that you enjoy this lecture, and I'll be back. Okay, have a great afternoon.